Hey everybody, Mr. Simone here. The purpose of this video is to be able to convert repeating decimals to their equivalent fraction form. This can be a little bit tricky for some students as you start to learn. This is the first video of a two-video segment. In the first video, this one will look at a little bit more basic repeating decimals. And the second video, there'll be some more trickier things to kind of think about. All right, so the first thing to think about is let's say, for example, we have a repeating decimal. Let's say it's 0.4 repeating. A lot of times teachers will either give you a decimal with a value with a line over it that shows that it repeats, or you may see it as something like this, where it's 0.44444 repeating. Okay, but that one digit of 4 is being repeated infinitely. And our job is to try to figure out, well, what is the fraction that's equivalent to that? Now, there are a few steps that we go over in class, and hopefully it'll help you as you go through. The first thing is we want to assign this 0.4 repeating with a letter. Any letter you want, a variable is fine. Let's just say we use m. So m is going to represent this 0.44444 repeating infinitely. The second thing you want to do is you want to think about how many digits are actually being repeated and try to duplicate that with powers of 10. So if one number is being repeated, which it is here, we would multiply it by 10. If two digits are being repeated, like 252525, we multiply by 100. If three digits are being repeated over time, we multiply by 1,000. So it all depends on place value and how many of that digits are actually being repeated. So step 2 in this problem would be to multiply both sides of our equation by 10. So 10 times m and 10 times this decimal that is being repeated infinitely. Again, we use 10 because it's showing that one digit is being repeated multiple times infinitely. The next step we've talked about in class is we have to try to get rid of that repeated decimal. Okay, so we end up with 10m is equal to 4.44444 repeating. We want to try to get rid of that decimal value. Well, how do we do that? One way we can do it is using subtraction. We are going to subtract our original amount, all right, from both sides. So we're going to subtract m from the right side. What you end up with is when you subtract by m on the right side, the left side, you're going to end up with 9m. You have 10 m's and we're taking away 1. In an equation, which is a balance act, whatever you do to one side, you have to do to the other. The only problem is we can't really truly subtract m on the right side because they're not like terms. But we did designate what m is. M is this, 0.4444 repeating. So I'm going to subtract by m in its other form of 0.4444 repeating. Now, why do I do that? Well, the ultimate goal is to try to get rid of that repeated decimal amount. When I subtract by m on the left side and m on the right side in a slightly different form, I end up with 9m equals 4. When solving equations, we're almost done. We have one more step to do. We want to try and get that m by itself. To do that, we are going to divide by 9 on one side and divide by 9 on the other. So our final answer to this whole problem is that m is equal to 4/9. If you can simplify further, or as some teachers say, reduce, you can do that as well. But what is m? M is 4/9. But what did we say m was originally? M originally was 0.444 repeating, or 0.4 with a line over it. So the equivalent amount is, in fact, 4/9. All right, let's look at another example. Let's say we had 2 digits being repeated. Let's say it was, 212121. So now we have 2 digits that are repeating infinitely. The same process still kind of applies. We start with identifying a letter that represents this. Maybe we'll choose x. X is 0.2121 infinitely. How many digits are being repeated? Well, 2, right? There are 2 digits. So a power of 10, or 2 powers of 10, which would be 10 and 10, would be 100. We're going to multiply both sides of our equation by 100. When you do that, you'll end up with 100x on one side and 21.2121 infinite. We're going to subtract our original amount in an effort to try to subtract out that repeated decimal amount. On the left side, we know that x, which is this, can be subtracted from 100. We get 99x. The same thing on the right side, we're going to subtract by x, we just have to make sure that it is in fact like terms. So what is x? X is in fact this amount. When I subtract, on the right side I'm left with 21. And now there's only one step left to do, which is to divide by 99. So x is equal to 21 over 99. Now, if you left this on a test or a quiz, you would lose half a point. We do want you to simplify. Some teachers say to reduce. The way to do that is to find out what they have in common, and we are going to divide by 3 on the top and bottom. What you end up with is, in fact, 7 over 33 as your final answer. Now again, we're not necessarily dividing by 3, we're actually dividing by 3 over 3, which is 1. Any number divided by 1 is itself, so we are saying that 21/99, yes, we're dividing by 3 on the top and the bottom, which is actually like 1, we end up with 7 over 33. All right, we're going to do one more example before we move on to our second video. So let's say, for example, you have 2.18 repeating, which is the same thing as 2.1818, so on and so forth. So what are we going to do here? This is slightly different than the other problems because now we have a piece in front of our decimal that we have to work with. The same principles will apply to these types of problems. Again, that second video that you'll watch has some trickier ones. So we need to identify a letter. Let's say A. A is 2.181818, so on and so forth. How many digits do we see that are repeating? Well, there are 2. Again, we're going to multiply by that 100 to help us. 2 powers of 10 is in fact 100. Whatever you do to one side, you have to do to the other to keep the balance. We are going to end up with 100A on the left and 218.1818 repeating infinitely on the right. We're going to subtract out our original amount because, again, we want to try to get it so that we only have our 0.18s to cancel out. On the right side, we're going to subtract out A, which is in fact 2.1818. Do the same thing to the other side, and again, we can't necessarily subtract this specifically the way it looks from 100A because they're not like terms. We're going to subtract out the A, which again is equivalent. You get 99A is equal to, all of these will cancel out, and this is the tricky part. We're going to end up with 216. Last step to divide by 99. So our final answer to this problem is A equals 216 over 99. On a test or quiz, I'd accept this. If you can try to simplify, that's fine. But these are 3 examples that we have worked with, and probably the 3 different types that you'll see most likely on an assessment. Remember that there are shortcuts that I've showed you. Anytime you have any digit, let's say it's 5 being repeated, you know that you can just write 5/9. All right, if you have 2 digits repeating or even 3, like let's say it was 375 repeated, remember that is the same thing as saying 375 over 999. Some little tricks that we do use, but if I do want you to show your work mathematically, these are some of the steps that you're going to see. All right, keep working.